Good morning and welcome everyone. Thank you for joining us today for this BSI webinar on the second generation of the Eurocodes. I'm Cara Ebanks, a Senior Standards Manager for the Built Environment at BSI. So to start with a little bit of housekeeping. So this is a listen-only webinar, so your microphones and cameras are automatically disabled. Submit any questions you have. We really welcome all the questions that are burning and that you're wondering about. So submit them through the portal, and we'll have a session at the end to go through them. For any technical issues, please report them through the same questions button as well. And after completing the post-event feedback survey, we'll provide a link to the recording. And also, this is a CPD accredited webinar. So to request your certificate, please complete the survey. We host many events throughout the year, and scan the little QR code there for some more information. Okay, so today's webinar focuses in particular on EN 1990, the basis of structural design, and EN 1992, the design of concrete structures, alongside an update on corresponding UK national annexes. And these documents are an especially important part of the Eurocode suite and are referenced right across many of the parts of the codes. We're pleased to be joined by experts who are directly right involved in the thick of it in both the European level and the UK development work and the UK implementation process. And our speakers today, who I welcome: Steve Denton, CEN/TC 250 Structural Eurocodes Chair and Managing Director Civil of WSP. Steve will be giving us an overview on the updated codes. And next, Mungo Stacey, B5251 Actions and Loadings and Basis of Design Chair, as well as Chair of TC 250 SC1 Eurocode 1, Actions on Structures, and Head of Profession at WSP. Mungo will be giving us a deep dive into EN 1990 as well. Tony Jones, B5252 Structural Eurocodes, Structural Use of Concrete, and Chair of CEN/TC and Technical Director at the Concrete Centre. And he's going to be giving us a deep dive into EN 1992 on Eurocode 2, the design of concrete structures. And finally, my colleague Deirdre, the Lead Standards Development Manager at BSI, and she's going to run through the publications timeline and give us an update on the national annexes. And as I said, there'll be an opportunity to submit questions right through the session, which we'll address at the end. And we're also keen to highlight where draft UK national annexes are open for comment as well, and how you can get involved in their final content. I hope you find today's session useful. And now I'll hand over to our first speaker to begin. Steve, over to you.
Cara, thanks very much. And good morning, everyone. So the main event this morning is very much hearing from Mungo and Tony, who have been instrumental, as Cara said, in the development of the Eurocodes, and they're two of the UK's foremost and most impactful experts in this area. So you're in very good hands. I'm just going to give you a very brief introduction. The Eurocodes, as you'll understand, are the design standards for buildings and civil engineering works. They cover all aspects of structural and geotechnical design, and they play a really fundamental, a key role at the heart of the European standardization system for the construction sector. The second generation Eurocodes are an evolution of the first generation documents. There is extended scope. There are new parts, as you can see from this figure. They have been brought up to date with some of the latest research and best practices, and they embed new needs, new societal expectations, such as coverage of climate change. Again, if we move to the next slide, this has been a major undertaking. Again, as many of you will be aware, the work on the evolution of the Eurocodes for the second generation initiated around 2010, 2011, and the sort of detailed technical work started in 2015. So it's been over a decade of effort. And in fact, this program has been the largest standardization program of its kind ever in European history by funding levels from the European Commission. So it's been a very, very significant and sizable project. Again, if we move to the next slide. And throughout the evolution effort, as TC250, the committee that has overall responsibility for the Eurocodes, we've had a clear set of overarching aims. First and foremost, to seek to improve to enhance ease of use. Clearly, a lot of things we do as civil, structural, geotechnical engineers are inherently complex, and we shouldn't shy away from that. But that's not a reason why standards need to be more complex than they need to be. And so that focus around ease of use has been central to our efforts. Ultimately, you'll be the judge of how well we've done, but I can assure you that this has been central to, I think, pretty much every meeting that I have had on the Eurocodes. We have talked about this topic. Then achieving exemplary levels of international consensus are fundamental in international standardization work, and I'll touch on that in a second. Thirdly, to deliver to schedule, which when you have thousands and thousands of experts from across Europe working collaboratively on such a complex and interdependent program was always going to be a challenge, but critical that we delivered on time. And then finally, to effectively communicate the changes and support all of those people affected by the transition. And today is an effort to try and support that communication and support that transition to the second generation of Eurocodes. And then if we just move to my final slide, I thought it might be of interest to you if I just share a few facts and figures. So CEN TC250, the committee with overall responsibility for the Eurocodes, is really substantial. Last time I counted them all up, we had 129 subcommittees, working groups, task groups involved. So it is a huge organization. As I mentioned, the Eurocodes sit within the broader family of European standards for construction. And so the interfaces across the product standards, execution standards, testing standards is really fundamental. And so throughout this program, we've had active liaisons with 46 different technical committees to try and make sure that there is full alignment between all of the different standards that are referenced and interface within those families of standards for the construction sector. During the program, we established through international competitions 76 European Commission funded international project teams who did a lot of the core work. And again, it starts to give you a flavor of the scale of the effort. We have had thousands of experts across Europe engaged in this work, somewhere between 1,500 and 2,000 at a European level. And when you take into account all of the mirror committees that exist, I suspect that it's probably been over 10,000 experts who've been engaged in this overall effort. So a really significant program, huge contributions from across the 34 members of CEN and more broadly. Building consensus and transparency was fundamental to the work. And so, of course, we have followed all of the usual standards development, CEN and BSI processes, but we've also built in many, many additional opportunities for comment. Over 300 formal opportunities for comment during the development of the documents. Every time with those comments that we received, collated, responded to by expert panels. So just a huge amount of work there. All of the European Commission funded work, all of the project team work, we delivered on time, on budget. We had no queries from the Commission on any of those deliverables, which was fantastic, particularly as we delivered many of them during the COVID period, which brought additional challenges. But most importantly, we delivered all of the second generation Eurocode documents on time. They were all released. The final package of documents were released in March. And in fact, we beat our deadline by a couple of weeks. And that was a very, very significant achievement since we had set ourselves that deadline about 5 or 6 years in advance. And we met it. And then finally, on the consensus point, that we did achieve really an exemplary level of consensus. At the end of the standards development process, each of the 34 countries has the opportunity to vote whether they are happy with the final documents that have been produced. And of the over 2,000 votes that were available to be cast, and just 7 of those were cast negatively, and some of those for very specific reasons about individual clauses, which have then triggered further conversations within the respective committees. But I'm sure you'll agree with me that 7 negative votes out of over 2,000 is a very small number and evidence of really an exceptional level of consensus that we were able to achieve. So that's a little bit of an overview. As I said, the main event this morning is hearing from Mungo and Tony who, as I said, are two of the UK's foremost experts in this area. Both have made enormous personal contributions to the work on the evolution of the Eurocodes. And so it's a pleasure at this stage to hand over to my colleague, Mungo Stacey, who is going to talk about EN 1990.
Great, thanks, Steve. So welcome, good morning, everyone. My name's Mungo Stacey. I'm the head of profession for the civil discipline at WSP, and in standardisation, I'm the chair of the UK Mirror Committee B5251, which has the responsibility around EN 1990, basis of design, and EN 1991 actions. At European level, I've also been active since 2015, since the outset of the second generation Eurocode programme within SC10, which is the European subcommittee that looks after basis of design. And as Steve said, there's been many opportunities for commenting, and I've been part of the SC10 management group that has been reviewing the comments raised on basis of structural design and updating the document to take account of those comments. And generally, when we've updated in response to comments, generally it has been to attempt to improve the overall document. At the UK level, in that role as chair of B5251, I've also had responsibility for leading the work on the UK National Annex. And so what I hope to do today is to give you some insight into both the development of the new EN 1990 and particularly some of the new features that are present within the updated document, and also to give you some insight into the emerging National Annex that will operate in the UK. In terms of EN 1990 and where it sits within the Eurocode suite of documents, I've put up here the diagram showing the relationship between the different Eurocode parts. You'll see extensive use of these new icons to illustrate the second generation Eurocode. EN 1990 is the so-called head Eurocode. It's the basis of design, and the other Eurocode parts then work alongside EN 1990. Throughout this presentation, I've also used the star symbol on the left-hand side of the screen there to illustrate some of the new features in second generation Eurocode compared with first generation. So that's just a bit of a prompt showing what's changed within second generation Eurocode. So first generation Eurocode on the left-hand side of the screen, we've been working now since 2010 with EN 1990, basis of structural design. The first key change is that in second generation Eurocode, that document has been complemented. It's now two parts to EN 1990. We have a part one, which gives us our basis of design for new structures. And we have a complementary part, part two, which is new content giving a basis of assessment for existing structures. Today, I'm going to focus on the part one, the basis of structural design. Actually, the basis of assessment would be a webinar in its own right, so maybe BSI will be doing one of those in due course. Given that that's new content, I've chosen not to focus on that today. I'll be talking about the updates just to basis of design. The two parts are designed to work together. So, for example, the numbering system is the same across both, so that you can cross-refer between equivalent provisions for assessment compared with the provisions for design. The next key change is that compared with first generation, which was basis of structural design, within second generation Eurocode, the geotechnical basis of design has been incorporated in EN 1990. So we have a combined basis of structural and geotechnical design. Now, that design basis for geotechnical design was formerly in EN 1997. And one of the enhancements of second generation Eurocode is to bring that together so that we've got a consolidated basis of design covering both structural and geotechnical design, all within EN 1990. So some of the content that was formerly in EN 1997 is no longer there. It's been moved and incorporated into the main basis of design. And I'll talk a little bit, giving some examples as we go through today's session. In terms of where we're at, and Deirdre later on will be talking about the overall timescales for second generation, but the BSEN 1990 part 1 and part 2 are now published. You can see on the screen there we have the 2026 documents. They were published at the end of March, so just a couple of months ago. a month and a half ago. So those are available. If you've got access to BS Online or to a standards portal, you should be able to obtain access to those. For EN 1990 Part 1, the basis of design, the National Annex is now ready in draft form and has been released by BSI through the draft for public comment stage. So it's not yet issued and available for use in live projects, but it is available for public commenting. And at the end of my presentation, I'll give a few more details about how to get access to that if you've got an interest in seeing where that is. Clearly, with second generation Eurocodes, the Eurocode is intended to be used alongside the National Annex. So until that National Annex is available, you really shouldn't be using that second generation Eurocode. So for those who do have that interest, don't start using EN 1990 just yet. You do need to wait until the National Annex gets published, which should be later on this year. There's also the subtlety that the Eurocodes are an interdependent suite of documents. So ideally, you should be looking to use all of the Eurocode provisions together for second generation Eurocode. How that works is set out in the National Forward at the start of each Eurocode part. Fundamentally, we're heading towards a 30th of March 2028 transition when the first generation of Eurocodes gets withdrawn and the second generation becomes across the board the default suite of documents. I'm sure Tony later will talk about some of the areas, particularly for concrete and some of the other materials where there may be advantages in using some of the new technical provisions earlier and how that may be done. So a bit then of a dive into what EN 1990 gives, and also a bit of reassurance, because many of the fundamentals of how Eurocodes work are either unchanged or very similar to what we've become used to with the first generation Eurocode. And when we start at the start with the basic requirements, the second generation Eurocode have the same fundamental requirements as were present in first generation Eurocode. And on the screen here, those 3 bullet points, we have to design for ultimate limit states, that we can sustain the actions and influences that are applied to the structure. We need to meet serviceability requirements, and we need to provide the specified durability over the course of the design life of the structure. And those are the same basic requirements as were present in first generation Eurocode. We also have, as we did in first generation Eurocode, the robustness requirements that we aim to have structures that avoid disproportionate collapse. One thing that you will see here is that there is a change in the clause numbering. So these basic requirements were in clause 2.1 in the first generation Eurocode. Pretty much across all of the Eurocode parts, there are 2 new sections that have been introduced due to the SEN drafting requirements. So most of the key content, you'll see there's a +2 on the numbering. So these are now in clause 4 rather than clause 2. It's also quite a quick way to check if you get a query from someone with a clause reference and the clause reference looks wrong. It may be because they're using the wrong generation of Eurocode. That's quite a nice quick way to check that you're using the right set of documents. Similarly, the fundamental combinations of actions that we've become familiar with using in first generation Eurocodes, and I did many Eurocode training sessions, and we always talked about equation 610, equation 610 A and B. You'll be pleased or not to know that those equations are still present in the second generation Eurocode. Again, the numbering change kicks in, so we now have formula 812 as shown on the screen, which does the same job as the former equation 610. We've also got those equations 610A and B, now formula 813, which gives the slight reductions with reduction factors either on the permanent action or on the leading variable action. Those remain in place. So there's some reassurance there, as Steve said earlier. Eurocodes in second generation are an evolution, not a revolution, and these fundamentals of how we apply the partial factor method remain the same in second generation. At the bottom of the screen there, there is what appears to be a third option as formula 814. This was actually present in the first generation, although it was somewhat hidden as a footnote to one of the tables. This was used by some of the European countries. It wasn't implemented by the UK, and that will remain the case in the second generation Eurocode. We expect the National Annex will give the choice between 812 and 813. Obviously, if permitted, then 813 will give a more advantageous answer. for which will be the case for buildings, for bridges, as in first generation. We're expecting the choice to be Formula 812 as it was in first generation. I mentioned earlier the combination, the amalgamation of the basis of geotechnical design alongside basis of structural design, and you can see how this plays out in some of the fundamental expressions in this section on verification by the partial factor method. On the right hand side of the screen, we've got the same basic terms, but we also have the addition of the XRD, the material term. Clearly, when you're looking at the design effect of actions, if you do have geotechnical materials, and if you consider, for example, horizontal earth pressures, then it's clear that the magnitude of that action, the horizontal earth pressure, does depend on the material parameters, the strength of the soil. So hence we have the XRD, the material strength term, coming in on the action side. And that was previously present in EN 1997, but not in EN 1990. So we now have a consolidated design basis, which covers both the geotechnical effects and the structural effects. I mentioned earlier the training that we did formerly for first generation Eurocode. One of the challenges with first generation Eurocode was you often had to recreate a table very much along the lines as shown on the page, where as a trainer I would explain which of the psi factors, which of the combination factors applied to the leading and the accompanying variable actions across the different combinations. In the first generation Eurocodes, that was only described through the formulae. In the second generation Eurocode, it was recognized for Steve's principle of ease of use, that it is actually helpful to have this content that shows the difference between the different combinations. Those tables are now included in Annex A. And the way EN 1990 is structured, the main text gives the formal principles. Annex A is intended to give the application for day-to-day use. And so this kind of table gives the ready lookup to show you how to apply the formal equations, the formal formulae that are given in the main text, and how those apply in day-to-day use. In the Annex A, we also have the sets of partial factors. Now, there are some changes here, more to the terminology than to how it actually works in design calculations. And for those who've used and are familiar with first generation Eurocode, you'll be familiar with the STR, EQU, and GEO ultimate limit states, and the corresponding set A, set B, set C partial factors, which were given in some fairly complicated tables as separate sets of partial factors. The terminology is changed in second generation Eurocode, so you'll no longer see references to the STR, EQ, GEO, but we still need to undertake those verifications. They're now termed verification cases. We have the VC1, VC2, VC3, VC4 sets. To give transparency of the differences between those verification cases, all of the partial factors are given in one table. It's this table A1.8. It is a nationally determined parameter because partial factors are a matter of safety and economy, so those are set nationally. So you'll see on the screen here, this is table NA3. It's an extract from the National Annex. And we have in the different columns the different partial factors that are given for those different verification cases, covering structural or geotechnical resistance, covering the equilibrium resistance or uplift, and for, on the right hand side, the geotechnical design. What we have also chosen to do in the UK National Annex is to indicate using an asterisk where a particular value is modified in the UK National Annex compared with in the core Eurocode. And in this table, actually, there's only one value which is modified. It's the value under VC4 for a gamma Q reduced. And the change is that the UK has actually written in the specific numerical value, which is not given in the core Eurocode. Again, thinking about ease of use, the panel drafting the UK National Annex did recognise that that new table shown on the previous slide is complex. There's a lot of numbers there, and that when you are dealing primarily with one of the verification cases, so for example, if you're a buildings designer, you're dealing principally with structural resistance, you're principally working in verification case 1, it can be helpful just to have the values that apply in that verification case. And so in the National Annex, we are proposing to include some corresponding tables, verification case by verification case, which just gives the unfavorable and favorable values for the different actions. And an example of that here shown on the screen. One of the changes that has been made concerns equilibrium and how that works. A classic case here, if you've got a continuous beam with a cantilever portion, one of the checks is about the stability of that beam. And as we start increasing the variable action, the QK on the right-hand side, what's the magnitude which could cause overturning of that beam, or correspondingly, at what point do we start needing an anchor at point A, which gives a reaction RA on the left-hand side of the screen. And there was a peculiarity in first generation Eurocode that as you started increasing the variable action, and the horizontal scale here is showing the proportion of the variable action to the permanent action, you could determine at low values of variable action on the left-hand side of the graph that you are satisfying equilibrium. And then as you started increasing the variable action, there came a point where equilibrium was no longer satisfied. And at that point, you need to switch from EQU to STR to work out the structural force in that anchor. And when you switch to the STR, there was a gap between the value at which EQU showed you that stability was provided, compared with the magnitude at which you started getting a non-zero or greater than zero value in the anchor. And that gap is shown by the blue shading on the middle of this screen. And that was problematic. It was not entirely clear what you were meant to do in that region where you were not satisfying EQU, but you were getting a less than zero resistance force in the anchor. So that has been tidied up in the second generation Eurocode now. The partial factors are such that EQU shows you that equilibrium is not satisfied, and the STR gives you the value of the anchor force, or rather the VC2 shows you that equilibrium is not satisfied, the VC1 gives you the anchor force needed. So that's helpful. It does mean, though, that the old 1.1 versus 0.9, where you had a sort of balanced destabilizing versus stabilizing under the set A values, that doesn't appear in quite that format. What we now get is under the case VC2, we get a 1.35 on the destabilizing versus a 1.15 partial factor on the stabilizing. The ratio between the two of those is chosen to be the same as the old 1.1 to 0.9, so you have the same margin against instability, but what you also get, though, is that because the 1.35 destabilizing is the same in the equilibrium and the structural resistance checks, you get this ability to also have the value of the anchor force that's required. In cases where you have the variable action dominating, then the VC2B kicks in, and in that case it's the ratio between the 1.5 on the unfavorable variable force and the 1.0 on the stabilizing permanent action that's important. And again, that ratio is the same as it was in first generation Eurocode. So we have the removal of conflicts between design for resistance and design for equilibrium. Robustness has been is still included, and guidance, the content of the main text is fairly brief, just one subclause 4.4, similar to in nature to first generation Eurocode. The operative provisions are given in Annex E. And one of the changes here is that a clearer distinction has been made between design for accidental actions, which is indicated here on the left-hand side of the table, compared with design for enhanced robustness. And what enhanced robustness means is where there is an unknown or unidentified accidental action, and you're considering strategies such as alternative load paths or notional removal of elements, and then making sure that the structure has a global ability to survive that event. On the left-hand side, design for accidental actions, where an accidental action is given, for example, in EN 1991-17, then you simply have to design the structure to resist that particular action. Within this Annex E, we've also moved across the content that was formerly in 1991-17, giving the principles for tie forces. There's no change to the underlying technical principles. So we will still use the same approach to design for robustness as we have done historically in the UK, using vertical and horizontal ties dependent on the consequence class. And the consequence class is now linked into Annex A1 of EN 1990 rather than being separately defined in 1991-17. Again, the list of the tables here aligns with the list in approved document A. We are in discussion with the building safety regulator about the concurrent update to that approved document. Great, and lastly in this main text, you will see in this table of partial factors that there is this KF multiplication factor, which is a facility for reliability differentiation. And one thing that is new in second generation Eurocode is this explicit link between the partial factors and reliability differentiation. Now that was present in first generation Eurocode, although it was somewhat buried in Annex B of EN 1990. That KF is linked to the consequence class, although the default choice in the UK will be that for all structures in is to use a unity value. So we're not linking. Sorry, I think I dropped out there just for a moment. I think I'm back now. There are some project-specific exceptions. So CC3B, CC1A give the opportunity to increase or decrease. However, we're expecting that will only occur in limited scenarios, such as for agricultural buildings, where that is already given. I'll just skim briefly through some other structural forms. So Annex A2 gives provisions for bridges, and those, it gives the combination factors, the partial factors. The numerical values will be the same as they were in first generation Eurocodes. We have some new content for bridges, particularly in Annex G, which gives a basis of design for bearings. And this was one of the bugbears of first generation Eurocodes, that it was very unclear what you were meant to do for bearing frictional and elastomeric forces and what you were meant to do for the design movement ranges. Those are now clarified in this Annex G for bearings. We also have some new content on serviceability limit states for accelerations and vibrations of footbridges. The UK content will be based on the approach given in the National Annex to 1991 Part 2 for traffic actions. There will be some new content for other types of structures, particularly towers, masts, chimneys, silos and tanks, crane supporting structures and coastal structures. Those will come out in new annexes A3 to A6. The content in the National Annex will follow on. It's not present in the draft that is currently out for draft for public comment. Looking ahead, there's also a proposed amendment to EN 1990. This is not yet available, but will be being issued before 2028, which will give a new informative annex on design assisted by numerical methods. And in particular, that will distinguish between the indirect method, which is the partial factor method, where you split out a design effects using the analysis, compared with the design resistance, which is given by the equations in the material parts, compared with a direct method where you use a single analytical model to establish the overall stability of a structure or element. So as I mentioned, the UK National Annex for 1990 Part 1 is now available for public comment. It's available on the BSI Standards Development Portal, and it's open for comment until the 10th of June. So there's a link that's just been shared into the meeting chat if you are interested in taking a look at that. We're expecting that National Annex and the National Annexes for many of the other Eurocode parts will become available either later this year or early into next year, and that will allow the updating of our industry guidance. So, for example, the iStruct-E is busy updating all of the Eurocode design manuals, and for example, I'm leading the work to update the manual for Eurocode 1 on basis of structural design. So there will be updates to industry guidance alongside the Eurocodes themselves. So thank you for listening. If you have got questions, please do pop them into the chat and we'll pick them up at the end. And at this point, I'll then hand over to Tony Jones, who will give a deep dive into the concrete part.
Hi, thank you, Mungo. Yeah, hi, I'm Tony Jones. I'm part of the BSI committee who have developed the national annexes for the new second generation Eurocode 2. I also sit on the European SEN committee responsible for Eurocode 2, representing the UK interests in that. So that's my background. Let's talk about what we've done in both Eurocode 2 and the national annex. So I'm going to talk about the main revisions in both EN 1992-11, the general part and the fire part. I'm then going to briefly look at the national annexes for the two documents and the PD that we've also produced with background to those national annexes. And then I'll just briefly mention other supporting standards, which are quite important. So the first thing to recognise is that in the update of Eurocode 2, the separate parts on bridges and liquid retaining structures have now been incorporated into Part 1.1. So the view was taken that the information in both the bridges part and the liquid retaining part was actually valid for other structures, and it seemed perhaps more political that there was a separation. So now in 1992-11, we have an annex which just provides a limited number of additional rules for bridges, and similarly we have an annex which includes a limited number of additional rules for liquid retaining structures. I'll just mention the other part to Eurocode 2, which is Part 4. Whilst that was not part of the mandate that Steve talked about at the beginning for updating all the Eurocodes, is that it is actually currently under revision, and part of that relates to trying to make sure we don't have discrepancies in the models which we use in the Part 1 to some of the models that we use in Part 4. So what we'll do now is go through section by section in the Eurocode to highlight the changes. I think, as was stated by Mungo, the first few sections are standard sections and set out standard requirements in the Eurocode. So I'm going to start at section 5, which is the materials section. Sorry, section 4, which is basis of design. Right. The first thing we've done is explicitly include a partial factor for the Young's modulus on concrete. Now, in first generation Eurocodes, that was included in certain sections, for example, for second order effects, but it actually wasn't very consistently dealt with. So now we start off and we have a factor for that. It's 1.5, which is actually an increase on the 1.2 typically used for second order effects. We also have a new material factor that we use for shear and punching shear resistance when you don't have shear reinforcement. This recognizes the fact that you get better calibration of the models with this factor from rather than just using the factor for concrete. The failure is in fact a combined effect of failure of concrete and steel. Finally, in the basis of design, there's an explicit link made between the tolerances you're using, which you specify through EN 13670, and allowances made in design. So then that opens up the opportunity in a transparent way that if you are specifying higher degrees of tolerances, you may then make different allowances in design. This was always an issue with, say, for example, cores in tall buildings and things like that. So now moving on to materials. Previously, the upper limit was a 90-105 strength. That's now moved to 100-115. So it's a moderate increase in the maximum strength concrete you can use. So in old money, it's now going up to 115 cube strength. What has happened is the concrete properties have been simplified. The first generation Eurocode had a term when defining the design compressive strength of concrete of alpha cc, and this was a rather vague term which was used to cover a number of different aspects of concrete behaviour that was, I think, used by national bodies perhaps to manipulate answers. Now we've got two factors which have very clear purposes, and the logic there is much better when you're trying to develop your design strength. By using these properties, it also means that for simplified design methods, we have the same strain limits when we're doing a sectional analysis for all concretes, which again greatly simplifies things, whereas in the first generation you had to start changing the strain limits when you got above C5060. Similarly, there's more transparency in how you determine the modulus elasticity, and it's directly related to the aggregate used. The National Annex will provide advice for UK aggregates and obviously a default position if you don't know the aggregate. There's also new models for creep and shrinkage. It's important to realise that with the shrinkage model, there is no size effect on the shrinkage at time infinity. So it actually is important now to consider the design life of your model when you're considering the design life of your element, when you're considering the appropriate design shrinkage to use. The new Eurocode introduces the concept of exposure resistance classes. And the point of this was that it gave a method where if you tested your concrete in a standard test, then you could directly relate that to the cover you needed. This table would be produced by the testing, etc., is the responsibility of another committee, and they have struggled to come to agreement with getting the results from a test translated into results that you can use with this table, which is a bit of a shame. So in the UK, initially we've aligned with the tables in BS 8500, but the hope is that when BS 8500 is updated, it will start to allow the use of exposure resistance classes as an alternative method of defining the cover you require. Moving into structural analysis, the advice in Eurocode 2 on no combinations removed, simply because, as we've heard, that is the remit of Eurocode 0, and it was never really the remit of Eurocode 2. However, given the nature of concrete and the fact that we have continuity and moment redistribution and cracking, etc., we have put simplified combinations in PD 6687 2026, which you'll be familiar with from previous guidance in national annexes and in the main code itself. The new code also presents a method to allow for creep relaxation of stresses. Been interesting to see how this is used by industry. So, if you consider, say, a settlement, then you get a set of forces in your structure, but because of the nature of concrete, it will creep and those will relax. So I think it'll probably have very specific uses, but it's there. We've changed the formula for moment redistribution. Those again who are familiar with the current code will know that the UK National Annex had a different formula to that given in the code. It's likely now that we'll adopt the method given in the code. Similarly, there's a method to explicitly calculate rotation capacity of concrete elements. There was a method in the current code, but it made a number of simplifications. So hopefully this will be an improvement. With regard to slenderness effects, this has been moved to an annex out of the main code, because it then being an informative annex allows nations to adjust the method to suit the way they're used to working in this area. There is, of course, the detailed general method there. In the ultimate limit state, we now have explicit requirements to consider torsional moments in slabs. So this is really recognising the fact that Finite element analysis of slabs is almost the norm now, whereas perhaps it wasn't when the first generation was being drafted. And we used to sometimes get arguments about where torsional moments were should be accounted for and how to account for them. So that's clear now. First generation Eurocode includes confined concrete, but it doesn't tell you how to calculate the confinement effect of reinforcement. That is now included in the Eurocode, second generation. However, what you find is that for typical columns, the consideration of confinement probably only adds about 5%. So I think it's going to be more useful in special cases where you want to take account of that confinement effect. There's a new approach to shear without shear reinforcement, and I'll talk about that in a bit more detail. And that counts for both the minimum shear resistance and the calculated shear resistance. When you have, again, a slab designed presumably through finite element methods, and you have shear in two directions, then you have to calculate the principal shear now, and you have to compare that to a corresponding shear resistance. Again, this was a very grey area in the last code. In fact, it just wasn't covered by the last code, because I think it wasn't really envisaged to work with finite element methods. When we talk about shear, there's a refinement added to the variable truss method for shear, which means particularly in the cases where you've got shear reinforcement, where you've got pre-stressing, you'll be able to get flatter struts and therefore more efficient design. Also, you have the ability to calculate strains in your strut, which again may give you a more efficient design with a flatter strut. The downside, if you like, on the negative side, it's recognized that reinforcement with ductility class A is not so amenable to these flatter strut angles, and that's penalized. So you have to have more reinforcement if you have class A reinforcement. Interface shear, previously it was purely a friction model, so you calculate the tension across your interface, and that gave you a friction force to take in interface shear. That model has been enhanced, but there's also been a new model which can be used based on the dowel action of the reinforcement crossing the interface, which is very handy if you've got low, small embedment depth, so you can't actually anchor completely the tension strength. And there's a completely new set of rules for punching shear. So the shear without reinforcement and the punching shear are all based on the critical shear crack theory. Now, this, in principle, is quite simple. It makes the assumption that as your crack opens, which is defined as a rotation, then the shear you can carry across this shear crack reduces. So you can draw one line, which is the reduction in shear with a rotation, and you can draw another line, which is a load deformation relationship. And where they cross, that is the capacity of your slab or in shear. Now that's okay in theory, but actually getting into the detail of doing this relies on an iterative effect. And what has been done in the code for the main design rules is a closed form solutions being made, which makes a number of assumptions. The equation I've given there, and then once you've got that equation, you can make adjustments for shear span and axial force, and so on. So that's okay, but what's interesting is that if you go into the Annex I, which is for assessment, it actually gives you the basic relationship. So it is possible for cases where you need to get more load out of an existing slab to directly consider the rotation and that failure plane and come to a solution. So the last page, as I was saying, where your principal shear is not in the direction of the reinforcement, you have this reduction based on cost to the fore on the reinforcement area. So that is quite a penalty, which is something that's not really been considered previously. So in that equation I showed you, there was a parameter dg, and that is a parameter that describes the failure zone roughness, and that in turn is a function of the aggregate size typically. And the equation is given at 16 mil plus D lower. For many UK engineers, the next question is, what is D lower? D lower has always been there in EN 206, but in 8500, which is the UK implementation of EN 206, it's not so well covered. Basically, it's the smallest value of the maximum aggregate size that you're going to permit in your specification. So in the UK, typically, we wouldn't specify a range for our maximum aggregate size. We would say, D max is 20 mil for a 20 mil aggregate, and therefore D lower becomes 20 mil. It's worth noting, it's hinted at in the code, and we expand it in the national annex, that just specifying D lower may not be sufficient because of the tolerances. You can specify D lower and end up with not very much of that aggregate. So we recommend an intermediate sieve size. Into serviceability limit stay, there is a simplified method to control cracking. We found it very conservative, so we've provided an alternative method in PD 6687. The refined method to calculate crack width has been fully updated, and we should find more efficient designs, particularly in cases governed by tension. So that will knock on into things like restraint cracking. There'll be quite a benefit there. And the other real benefit, again, reflecting the way that engineers work now, is there's a new method for estimating deflection based on deflections from an elastic analysis. So we can take a deflection out of our model and apply a factor to it, much like ACI do, and get a better estimation of the real deflection. Just going rapidly through detailing, we have new rules for mandrel diameters. There's also a new method which allows you to have multiple smaller mandrels, which works better where you've got an automated process doing your bends. There's a new anchorage and lap length equation. The result of that is that some anchorages will be a bit longer, some will be a bit shorter, but there's also a number of additional cases considered. So here we see we've got we can do laps with loops, with headed bars, and even post-installed bars. I've just flagged there that there is a factor on the anchorage length to get a lap length. The UK National Annex has set that at 1 because other changes to the NDPs in the anchorage equation have been made, and we found that that was a better approach. There are no standard minimum reinforcement percentages. It's all based on theory now, and simply gives you the issue of making sure that the crack section is stronger than the uncracked section effectively. In the National Annex, we do provide some simplifications to that for typical cases. We have a reduced minimum reinforcement for statically determinant members. And again, that was there hidden somewhere in the first generation. Now it's a very explicit rule. And what you find is if you use high ductility reinforcement, you can significantly reduce the amount of minimum reinforcement you use. And there's also new rules for integrity reinforcement in slabs. This is all based on a mechanism of a post punch and shear failure and hanging your reinforcement. What you'll see is the bottom reinforcement is the most effective. But if you've got links, you can take advantage of the hogging reinforcement. Again, you get a lot of benefit using higher ductility reinforcement. With precast, effectively the rules are the same, but they've just been pulled together more logically in this section, so I won't get into that. Now, what we have got is a whole set of new annexes. So Annex D on restraint cracking, those familiar with C766 will recognize it, but it is somewhat different. So you need to follow it in full and not mix approaches. There are safety formats for nonlinear analysis, which hopefully will match eventually with the Annex coming in EN 1990. We have Annex I, which I mentioned previously, on the appraisal of existing structures. We've got rules for CFRP plate strengthening with plates and also with near surface reinforcement. We have rules for design of steel fiber reinforced concrete structures. Again, this is steel fiber reinforced concrete structures generally working with normal reinforcement, not the case of only steel fibers. We have rules for using recycled aggregate concrete, rules for stainless steel, and I've already mentioned embedded reinforcement. The fire part has far less change. There was concern with some of the tables, and that has meant some additional limits being placed within the tables, and that will increase complexity in some cases. Also, the temperature profiles were removed because they were considered to be able to be derived from the formula that were given. Again, perhaps it would have been useful to keep them, but yeah. There's also been a few rules updated to reflect changes in Part 1.1. So there's also rules for steel fibers in fire and steel fibers and recycled aggregates in fire. It's worth looking at this if you're considering using recycled aggregates, because it is quite restrictive. So National Annex, they were all published at the end of last month. Sorry, 1st of March, month before. They follow the standard process of 4 sections: scope, the nationally determined parameters, decision on the informative axis, and the complementary information. To part 1, we include an annex on recycled aggregates, and the main purpose of that is not to change what's in the annex in the Eurocode. It's just to align the terminology with what's in BS 8500. So it's worth mentioning PD. We've given the background to UK decisions on NDP. We've given some complementary commentary on some specific clauses and guidance on stuff not covered in the Eurocode, and we've also made reference out to the building regs as appropriate. Obviously, as we could have complementary information in the National Annex now, it was a bit of a decision as to have what should be in which document. What we've generally done is stuff that we felt you really needed to use the Eurocode is in the National Annex. The stuff we think might be interesting and help people go beyond the code we put into PD. The thing to note is that we have yet incorporated the Bridges PD 6687 Part 2 2008 into the new PD, but that's a process we're going underway at the moment. Going forward, we're expecting some amendments to come out, and we will have to update the National Annex to align with that and the PD as well, including the additional bridge-specific guidance. Just mentioning other standards, I've mentioned a couple of times BS 8500. That's currently being updated to discuss D-lower in more detail and hopefully make it clearer for specifiers of concrete. It's also proposed that we will have a part that has exposure resistance classes in it. Reinforcement BS 1249 is also being updated. That will hopefully include, when it's published, an annex on grade 600 reinforcement. So you'll have the opportunity to take advantage of the clauses for higher grade reinforcement in the Eurocode. And the execution standard is also being updated to align with the new Eurocode. Precast product standards are being updated. they will initially be updated to the old Eurocode, but then immediately updated again to the new Eurocode. That can do a whole presentation on that if you wanted. So we've got extensive changes. The UK NA and the PD are out now, taking account of what Mungo said. It's better to use the whole suite, but I think there are parts of the second generation Eurocode 2 that people might want to start looking at now, either in parallel to using the current code, or because the current code doesn't cover those matters. And in any case, it would be a lot better to iron out any issues prior to March 2028. Okay, thank you. I'll now hand over to Deirdre.
Thank you, Tony. So good morning, everyone. My name is Deirdre Ferry, and I'm a Lead Standards Development Manager responsible for managing the BSI committees that provide UK input into the Eurocodes. So today we've heard a little bit from our speakers about the technical aspects of the Eurocodes, such as EN 1990 and EN 1992, as well as their corresponding national annexes. But I'd now like to take the focus to the practical side, particularly the publication timeline and the national annexes schedule. Just before I begin, I'd just like to take this opportunity to say a huge thank you to our speakers and the wider BSI Technical Committee experts. Their contributions have been extremely valuable, not just on the two codes we've heard about today, but across the entire second generation Eurocodes, and not to overlook the time and effort that they've been putting into drafting those corresponding national annexes, which set out those UK decisions on matters which are left open for national choice within the Eurocodes. So let's move on and take a look at the publication timeline and the schedule for these national annexes. So on the screen, you can see this slide highlights some key dates that have helped us plan ahead. A major milestone was recently achieved, which we heard about earlier from Steve, and that was with the release of the final package of the second generation Eurocodes linked to Mandate 515. And obviously this also happened ahead of the date of availability, which was always set for the 30th of March 2026. So this work was guided by the CENTEC 250 committee, which was obviously chaired by Steve Denton and managed by the BSI Secretariat under my colleague Tracy Wilkins. Another significant date on that table is the 30th of March 2028. This is what we call the date of withdrawal and the date by which all the first generation codes will be withdrawn. So since the second generation Eurocodes began their release in 2023, our BSI practice has been to make sure we make these available as BSENs as soon as possible. And this is also to allow users to prepare for the transition from first to second generation. Many of the codes will also go through an early amendment stage, and this is mainly just to bring references to other Eurocodes up to date. And these amendments are expected to be made by the date of publication of the 30th of September 2027. At the same time, our BSI committees are focusing on completing the national annexes, and some parts, such as the EN 1992 parts, which we've heard about from Tony, have already been published. And we're working with the committees and the panels to ensure that the remainder of the national annexes are available at least by September 2027. That will give us a lead time of at least 6 months before the date of withdrawal, and also help users to plan for that transition effectively. So if we could move on to the next slide, please. And so far, just in terms of the national annexes, we have published 17, and the remainder are expected to publish between now and into 2027. As part of the national annex development process, there is a draft consultation period, and this gives stakeholders the opportunity for them to comment on the national annex drafts. Any comments that you might have can be submitted via our BSI Standards Development portal, and there'll be a link on within this presentation. Of note, as we heard earlier, the national annex to BSEN 1990 Part 1 is currently at DPC, which is the draft public consultation stage. And this is expected to be published within a few months. But if you'd like to provide some input and your comments, please do visit the link that was shared via the chat and will be shared within this presentation to that site. Another thing that we're doing within BSI to support planning is making sure we're preparing a comprehensive list of all the published and forthcoming national annexes, and this will be made available. It will include key dates such as the expected publication timelines, the draft consultation periods for those national annexes at that stage, and the goal is just to make sure we increase engagement and ensure that there's a smooth transition for all users. And finally, on the last slide, please, if you could just move on to the next slide. Thank you. If you'd like to get directly involved in any of our committees, please do visit the link that's on the slide on how to get involved. You can also contact me directly. Again, the link to the standards development portal where you can comment on national annexes is also on the slide, as well as a link to our BSI knowledge page, where we're looking to have all the published and national annexes and BSENs available. So I hope that's given you a little bit of an overview of the publication schedule and the ongoing development of the UK national annexes. And yeah, I'm going to now pass over to my colleague Cara for some questions.
My microphone wasn't going to work then. Thank you very much, Deirdre, and thank you very much to all of our speakers. I'm going to canter along because we have run slightly behind schedule. So if all the speakers wouldn't mind popping their cameras back on, that would be great. And while that goes ahead, we've had one of the questions that came in were, will the slides be available? Particularly, Tony, it was your slide deck. And yes, if you just fill in the feedback survey at the end, we'll get the slide deck sent out as well, and all of the slide decks of the speakers. As I know there were some key dates and some of the text was quite small and whatnot on some of the slides. Okay, so moving on, and again, we've got about 5 more minutes, so we'll get through as many of these as we can. We're not going to get through them all, so I'll look into and work with our marketing team to getting answers to them and distributing them alongside the webinar information and slides as well. So first one, Mungo, if you wouldn't mind answering this one. So one of the questions that came in was, what changes are coming for wind and snow loading, and will the current maps be updated?
So actually, it's outside of the topic of this presentation, because that's really a question about the actions, but fortunately I am in a position to be able to answer it. So you might be aware that one of the things that second gen Eurocodes does is introduce a climate change factor on most of the climatic actions. So we do need to consider, if you've got 50-year life or 120-year life structures, there will be a new climate change factor applied to the environmental actions, including wind, temperature, snow, atmospheric icing, to take account of how those climatic actions might change during the design life of the structure. Through B5251, we have undertaken work to review Met Office projections for the various climate scenarios into the future, and it's looking likely that snow levels will generally reduce, although there might be some greater variability. Wind will generally stay the same and temperature will increase somewhat. And on the back of that, it's currently not anticipated that significant changes to the wind or snow maps will be needed. We are working with other experts to review updates to temperature maps to take account of that and to include these climate change factors within the national annex decisions for those parts, EN 1991, 13, 14, 15.
Great, thank you. And Tony, a little bit of a technical one. I don't profess to know what this means, so I'll read it out. Can you explain the background for reducing the construction load combination factor from 1.0 to 0.8?
Construction, sorry, Karen, no, I'm not sure I understand that either.
So what's the rationale for reducing the construction load factor, combination factor, from 1 to 0.8? No? Odd question. We'll take that one away.
Yeah. I mean, there is a factor that we use for deflection, and that's somewhere between 0.5 for long-term effects and 1 for short-term effects. And we say for construction, use a value of 0.8, maybe that's it. But that's simply because work carried out by various researchers on buildings during construction have found that that's a good compromise between 0.5 and 1 for the construction stage.
Right. Okay. Thank you. I think that was probably it. This is a question that we get frequently asked. And I really want to ask this one to anyone, really, but because I think it's important. So with the updated standards being available for public comment, so obviously we've got the ENs all published and they're going through early amendments, and the national annexes, some are published and some are through for public comment. So there's a lot of going on in tandem, but when is it anticipated for the new Eurocodes to come into effect? So I put that either to Mungo or Tony. So essentially, when should people start using them?
Do you want to go first, Tony, and then I'll supplement?
Yeah. The official date is March 2028 when the old version, when the current Eurocodes are withdrawn. So you really should be, if you're starting a new project on the 20 whatever it is of March in 2028, then you should start with the new Eurocode. Obviously, what we'll have to see how approved document A is updated for buildings, but our understanding is that will align with that. I suggest that there is opportunities to use the codes before then. You need to read the foreword and take account of what it says to each of the Eurocodes in terms of, you can't use it until the national annex is there, and once you've got it, your code and the national annex, you need to see what the interactions are with other codes that may not be published with their national annex at that point. But in general, I don't see it, that the overall reliability that you're trying to get from each part of the code is the same. So there shouldn't be too much of an issue in using the first generation with the second generation, providing you pay attention to what you're doing. Obviously, it would be a disaster to use first generation steel and concrete composite code with the second generation concrete code. That wouldn't be a good thing to do. But in other cases, I think it'd be okay.
Yeah, and I fully agree with what Tony's just said. The only thing I would add is, so I do a lot of work in transport infrastructure, and what we're expecting is that many of the key transport infrastructure client organizations will probably mandate a switchover on a particular date, which is likely to be 30th of March 2028. So for example, we know that Network Rail, National Highways are busy looking at updates to their own client documents to make them compatible with Eurocodes. Obviously, if you have a project that's just gone into contract prior to that, there will need to be decisions for projects that are in flight as to whether those change Eurocode set or whether they carry on with what they're going with. But certainly for major infrastructure projects starting after March 2028, we'd expect second generation Eurocodes to be the default choice. Equally, as Tony said, there is opportunity to use some of the more advanced technical provisions early, and I'm aware of major infrastructure projects where that has already been done, usually through departures from standards, to take advantage of particularly aspects that are not covered in first gen, where there are beneficial provisions in second gen. So some of the lap arrangements that Tony was illustrating, certainly I've made use of already.
Super, thank you. One very quick last question to Deirdre. Lots of interesting questions, lots of interesting information. Will there be similar webinars for Eurocode 3, 5 and 7 and probably others as well? Are we planning other webinars, Deirdre?
Absolutely, and the main focus as part of promoting awareness of the second generation is to have more of these spotlight webinars. So we'll be planning another one hopefully in September 2027, and we'll be sharing some details about the actual detail around what that will cover in due course. So stay put.
Super duper. Thank you very much again to all the speakers, and thank you to everyone who's joined us today. The second generation of Eurocodes and national annexes are such a key part of the future of structural design, and we really need your engagement in their development. Look out for all of the information that goes on our webinars. We've got some videos coming soon. We're going to have a dedicated website as well. So watch this space. There's lots of more information coming through. And yeah, as Deirdre said, there'll be another webinar in September. And thank you. We've got all of the details of future webinars that BSI hosts up on the screen now. And that's it. Thanks very much for your time, and enjoy the rest of your day.
Thanks for listening, everyone.
Thank you. Bye-bye.
Thank you.